Okay, let's look at number 5 in 6.1. We're going to consider these two functions. This is a cubic function, and this is a linear function, just a line of slope 5. We're going to plot these two functions on the same set of axes using a comma to separate the expression. So what are they talking about here? Well, they have a space for you to actually plug in the rule for the functions, right? Y equal f of x, y equal g of x, and you just separate them by a comma. And so literally in that box, you're going to write x cubed minus 11x, comma 5x, right? And it's going to graph both of those functions automatically for you, or it should, okay? So that's how you graph them or plot them. And from that, you should be able to see points of intersection, but we want to find them exactly. So how do we do that? Well, remember, we equate the outputs of these two functions to each other. So when is x cubed minus 11x equal to 5x? Well, subtract 5x from both sides. We got it set equal to 0, so I can now factor this side, factor out an x. That leaves x squared minus 16. That's the difference of squares, x plus 4 times x minus 4. And so these are our x coordinates for our points of intersection. And here's something what the graph should look like. There's that linear function 5x, and there's that cubic function, right? And you see the points of intersection here when x is -4, when x is 0, and when x is +4. But notice there's two regions that are enclosed or bounded by these two curves. And so we want to find the area of both of these. Now, region 1 is vertically simple. Notice the top function in this case is the cubic function. The bottom function is the linear function. For region 2, the roles are reversed, right? It's vertically simple, but the top function is the line y equals 5x, and the bottom function is this cubic function. And so when I integrate for region 1, I'm going to integrate from x equal what? -4 to 0. And I'm going to integrate the top function, x cubed minus 11x, minus the bottom function, 5x. Region 2, I'll integrate from 0 to 4. Top function is 5x. Bottom function is x cubed minus 11x. Okay, so each of these integrals then are easy to compute. I simplify both of these. Be careful here to distribute the negative through. And then I find the antiderivative for each of these. Evaluate this one at 0 and at -4. Evaluate this one at 4 and at 0, subtract. You'll notice that both of these integrals come out to be 64 square units. There's some symmetry here. Both these regions are actually equal. And so the total area is 128 square units. Okay, so lots of fun. Again, the key here is to make sure you find those points of intersection as needed, graph the functions clearly so you can see which is the top and bottom function for each region that you need to find the area of. Okay, hope this helps.